Hi everybody, this is going to be a complete walkthrough of the book review on pages 67 to 68, and you can see the numbers are listed here. So the first question is number 1, I'm going to find the exact values of the 6 trig functions for angle A in the figure. The important thing is that you're looking for angle A, so I'm going to note angle A, and I highly recommend you draw the diagram for question 1. So you can write number 1 and sketch out the diagram if needed. You don't have to. And we're looking for the 6 trig functions. So we're looking for the sine of A, the cosine of A, the tangent of A, and then we're also going to be finding the reciprocals. So let's start off with angle A, and we're going to identify sides opposite, hypotenuse, and adjacent. Okay, so this is our side. If you go over here, this is the opposite side. Find your hypotenuse. That would be this side right here, and that means this side would be adjacent. So if I'm looking for sine, cosine, and tangent, remember you can use SOHCAHTOA. Okay, let's start with sine. The sine is the opposite over the hypotenuse. Opposite over hypotenuse, so 24 over 40. And we're going to need to reduce that in a minute. Okay, let's look at the cosine. The cosine is the adjacent over the hypotenuse, so adjacent over hypotenuse. And we'll be reducing that as well. And then tangent is opposite over adjacent, opposite over adjacent. Okay, now all of these can be reduced, and I'm going to show you a quick way to do that on the calculator. So you could reduce this fraction by dividing out any common factors, like they both look like they divide by 4, so you could reduce it that way by dividing by 4. Another quick, easy way to reduce these is just to divide it out in this calculator. Okay, so you would take the 24 divided by 40, hit enter, and then you press math. The math key is up here right below that green alphabet key, and then you hit enter, enter. It's going to take your answer and turn it back into a fraction in lowest form, and that would be 3 over 5. So you could reduce it by dividing by, it looks like these are going to divide by more than 4, or you could just type it in, 24 divided by 40, math, enter, enter, and you reduce the fraction. Okay, you could do the same thing here. It looks like these both would divide by 8. Otherwise, I could do 32 divided by 40, enter, math, enter, enter. And you'll see that that one reduces to 4/5. So again, it's just a quick, easy way if you don't want to have to figure out what they have in common. And then you could do the same thing here. So 24 divided by 32, math, enter, enter, and that one's 3/4. This question is also asking for the reciprocals. Remember, sine and cosecant go together. Cosine and secant go together, and tangent and cotangent. Since you've already reduced these fractions, I would just use those as the reciprocals. So go ahead and just flip each one of them over, and then you'll have your reciprocals as well. For question 2, I'm going to copy down number 2, and then I'm going to draw out this entire table on my paper. And I'm going to fill in each one of these angles, 30, 45, and 60. As you're working through this video, if there's something that you've already seen or you don't need a particular problem, feel free to skip past that question. Okay, so I'm going to figure out each one of these trig functions. I know no other information, so the first place that I would start is I'm going to draw a picture. So I'm going to draw a coordinate plane for each one of these angles. So my first angle is 30 degrees. So I'm going to draw an angle that starts at 0, that's the initial side, and rotates around counterclockwise. So approximately there. Now remember, this isn't just an angle. What we can do with this is we can draw a point on this angle and drop a perpendicular. So this angle right here is 30 degrees. I'm going to do the same thing with the next angle, which is 45. Start here at this initial side, rotate around counterclockwise. This would be halfway in between. 45 degrees is half of that quadrant there, so there's my 45 degree angle. put a point somewhere on the angle and drop a perpendicular. So again, you're looking at a 45-degree angle. This third one is 60 according to the table here. So again, go ahead and draw a 60-degree angle. That's going to be a little bit more than 45, maybe somewhere up in here, just your best guess. And same deal, put a point and drop your perpendicular. And this is 60 degrees. Each one of these triangles then is a special right triangle. If this is 30 and this is 90, then this one would have to be 60 degrees. If this is 45 and 90, then that means this other angle up here is 45 degrees. And finally, we've got 60 and 90, so that means this one is 30. So we're looking at 30, 60, 90 triangles and 45, 45, 90 triangles. The book tells you if you don't know any other information, and we're trying to figure out the trig functions here, what you do is you let the shortest side equal 1. So that's what I'm going to do here. I'm going to look at my shortest side and I'm going to set that equal to 1. I don't know any other information and I'm trying to find the sine and the cosine and the tangent. I need the sides to be able to do that. Okay, so I'm looking at my smallest side of this triangle. The smallest side is opposite the smallest angle. So since this is my 30-degree angle, that's the smallest of these three, then this side would have to be my smallest side. The book says to let it equal 1. The hypotenuse of a 30, 60, 90 triangle is always double, and the other side is always square root of 3. Okay, let's do the same thing with this 30, 60, 90. The side opposite the smallest angle, that would be this 30-degree angle, is going to be 1. The hypotenuse is always double, and that third side then will be square root of 3. And that's just from the Pythagorean theorem. In a 45, 45, 90 triangle, the two sides are both the same, and they're both going to be the shorter sides. So those sides are both going to be 1, and the hypotenuse is going to be square root of 2. Okay, before we start labeling the sides with x and y and r, let's consider whether these are positive or negative. If you start at the origin and you go to the right, it's positive. If you start at the origin and go to the left, this would have been negative. But these are sitting in quadrant 1, so you've got a positive and a positive. Positive, 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 positive. If you were going to the left, it would have been negative, but in this case, all of these are positive. Okay, this is our x-axis, so that means this side will always be called x. The hypotenuse, that diagonal, the hypotenuse, each one of these diagonals was always called r. And remember, r is always positive. The hypotenuse is r is always positive. And lastly, the other side then would have to be called y. There's only 3 letters, x, y, and r. So if this is x, this is r, this would be y. And the y side is always parallel to that y-axis. Okay, now it's been a while since we've looked at these trig ratios, so I'm going to look them up. They are on page 22 in your textbook. So I'm going to bring those up and we'll take a look at them now. I'm in section 1.3. You can see page 22 would fall in here. And I'm going to find these trig ratios. Here they are. Okay, sine. And by the way, here's where I'm getting this x and y and r. Remember how we just labeled the sides x, y, and the hypotenuse is always r. Okay, the sine is the y over the r. So let's take a look at our picture. We want y divided by the r. So let's start with this 30-degree angle. Y over r would be 1 over 2. Reduce if possible. The cosine. The cosine of the angle is x over r. So that would be square root of 3 over 2. Let's look for tangent. The tangent would be y over x. So that would be 1 over square root of 3. And you have to rationalize it whenever there is a radical in the denominator. So that would just be root 3 over 3. The other three are going to be the reciprocals, but be careful, look at how this is written. When we worked with these originally, we had sine and cosecant are together, cosine and secant, and then tangent and cotangent. So just be careful when you write this out. The sine and the cosecant are on opposite ends, and they are simply just reciprocals. So if this is 1 over 2, it's 2 over 1. That reduces to 2. Okay, so the cosine was square root of 3 over 2. The secant will be 2 over root 3. Go ahead and rationalize. And then finally, tangent, cotangent are reciprocals. I'm going to flip the original. Do the same thing now for each one of the sine, cosine, tangent functions for 45 degrees. Okay, so go ahead and pause the video and try it, and then I will walk you through it as well. Sine is 1 over, it's y over r, so 1 over root 2. You have to rationalize it. The cosine is the x over the r. And the tangent is the y over the x. The other three are going to be the reciprocals, and I'm going to flip the original. Actually, I put that in the wrong spot. See what I mean? You've got to be careful. So I just did that. I put that in the wrong spot. The tangent and cotangent are reciprocals. So if this is 1 over 1, this is also 1 over 1. So sorry about that. I put that in the wrong spot. Sine and cosecant are reciprocals. So I'm going to do the reciprocal of 1 over root 2. And then secant and cosine are reciprocals. So instead of 1 over root 2, it's going to be square root of 2 over 1. And those are simplified. Okay, I'm going to go ahead and work on 60. If you need to pause the video and try it, do that. So 60 degrees, we've got y over r, square root of 3 over 2. The cosine is the x over r. If you have forgotten these ratios, feel free to look at page 22. That's where those trig ratios are. So x over r, and the tangent is the y over the x. The other three are going to be the reciprocals. Okay, now last time I messed up, so I got to be really careful. Sine and cosecant are on opposite ends here. So instead of root 3 over 2, it's going to be 2 over the square root of 3. And hopefully you rationalized it. Cosine and secant are reciprocals. And finally, tangent and cotangent. So instead of 1 over the square root of 3, or square root of 3 over 1, it's going to be 1 over square root of 3. And then I need to rationalize. So it'll be root 3 over 3. Remember, if you have some of these questions done, feel free to fast forward through them until you get to the question that you need. So in this question, what I recommend you do is draw out the picture so you can draw out the diagram. And what I would really do is I would make these into 2 separate triangles. So I'm going to do that now. So in this picture, it's important to kind of see how this triangle is oriented. This is your smallest angle of a 30, 90, this would have to be a 60-degree angle here. So I took these 2 triangles and I split them up. And that means if this is 60 degrees, this is a 45, 45, 90. Okay, so what we know about a 45, 45, 90 is that these 2 sides are congruent. So if we can find the other side, we can find the other. And the hypotenuse is whatever that side is times the square root of 2. In this triangle, this 30, 60, 90 over here, what we have to work with is the length of the hypotenuse. The hypotenuse is always double the shortest side. Let me say that again. The hypotenuse is twice as big, double the shortest side. So in order to find the shortest side, what I can do is take this 36 and I can split it in half. Okay, so remember our hypotenuse was like 2 times x, and if x equals 36, then you can divide it by 2 to find out what that shortest side is. So 36 divided by 2 would be 18. Okay, so our shortest side in this case is W, and our longest side is 2W. So what I'm really finding is W, which equals 18. Now, the reason that helps me is that's the side also in this triangle right here. So W equals 18 as well on this picture, since they share that common side. Okay, now what we saw earlier is, since this is a 45, 45, 90, think about this. If this side is 18, then doesn't that also give you this length? So this length would also be 18. And the hypotenuse is going to be 18 times the square root of 2. Well, you don't even need that times in between, so it's just 18 root 2. We've got one last side to find, this side over here. Okay, so if this is the smallest side, and that's 18, and this is the longest side, and this is 18 times 2, this other side was always 18, or whatever the number was, times the square root of 3. So this side over here will be 18 times the square root of 3, which is just 18 root 3. So there isn't going to be a question on the quiz that was as difficult as the homework problem that we saw a couple weeks ago, but there definitely may be a question similar to this on the upcoming quiz. One that's definitely doable if you just kind of break it apart and take it one step at a time. Find the exact values of the 6 trig functions for each angle. Rationalize the denominators when applicable. The first thing you're going to do to start off with this question is draw a picture. There is no other given information, so let's sketch out 135 degrees. It starts here at 0. 90 degrees would be straight up, 180 would be all the way over. So somewhere in between here in quadrant 2 is your 135 degree angle. In order to calculate this information though, the 6 trig functions for this angle, I need to draw a triangle. Just like we've been practicing, we've been working on some of these triangle problems. So what I need to do is figure out this reference angle, the angle that I'm going to use to calculate. So we used this at the very beginning of this chapter, and what we did was we had to figure out how many degrees would be left from either 180 or 360. In this case, we're just working with the top of the coordinate plane, so 180 degrees minus the 135 degrees is going to give us our angle. So feel free to use a calculator or just subtract it out. And I got 45 degrees. So the angle that I'm going to be working with is a 45 degree angle. Hey, we have a 45 degree angle. That means this is going to be 45, 45, 90. Okay? If I don't know any other information, then I can go back to this idea right here in this earlier problem where the book says to let the shortest side equal 1. So we know no other information other than the fact that we have an angle that we rotated, and this is a special right triangle. So let's let our shortest sides, in this case, both of the sides here, are going to equal 1. The hypotenuse is always, for a 45, 45, 90, square root of 2, and that's just from the Pythagorean theorem. In this example, though, this isn't a positive 1. This moves to the left, so that would be negative 1. So from the origin left, that's negative. From the x-axis up, though, that's also positive, so that's fine. Let's go ahead and label the sides. We need x. Remember, x-axis, that's always the side x. The hypotenuse is always r. And then the other side is going to be the y. And that's parallel to your y-axis, so that can help you as well. Okay, so we're going to figure out the 6 trig functions for this angle The angle is 135, so I'm going to write them all out. So I'm starting with sine 135, and I'm going to go ahead and write them all out. Okay, so again, if you have forgotten the trig ratios, you can look on page 22. Remember, sine is y over r. So I'm just going to write out the y over the r and then reduce if needed. I'll rationalize that in a minute. The cosine is always the x over the r. So that would be negative 1 over square root of 2. And again, I'll reduce in a moment. And then the tangent is always the y over the x. So that would be 1 over negative 1. And then go ahead and rationalize each one of these trig functions. Okay, so you can see that I got square root of 2 over 2, negative root 2 over 2, and then negative 1. Now do the reciprocals, and again, I always recommend flipping the originals. Go ahead and find the reciprocals of each. So this first one just it works out to be the square root of 2. The second one, I got negative root 2. And then the third one just simplifies to negative 1. Before I graph this angle, I'm going to have to find something coterminal. So I'm going to have to add 360 first. And then I'm going to graph out the remaining angle. Okay, so 90 goes up here, 180 here. So 210 would be somewhere down in this quadrant. Remember, what I'm looking for, though, is not the angle that it rotated. I'm looking for this little reference angle. If I go 360, that's going to give me all this unwanted information. So I just need to take out this 180 from the 210, and that will give me this little angle here. So I'm doing the 210 minus 180, and I get 30 degrees. So I'm going to put 30 degrees in this angle here. So that's 30. This would be 60. So my shortest side will be 1, and that's going to be the side opposite 30 degrees. The hypotenuse is always double. This side would be square root of 3. Look to see which of these are negative numbers. Start at the origin, go left. That means that is a negative. This number from the x-axis, you're moving down, that would be a negative. Hypotenuse is always positive. This is your x-axis. This is your hypotenuse, and that is your y value. Okay, you're going to write out the 6 trig functions for negative 150. Refer to page 22 if needed and fill out the first 3 trig functions. For this one, a negative divided by a negative makes a positive, and then I rationalized, so I got square root of 3 over 3. Okay, go ahead and do your reciprocals of these 3. So for this one, I got negative 2. For this one, I end up with negative 2 root 3 over 3. And then in this last one, I should have just the square root of 3. You'll notice this is a giant number. We're going to do the same process. So first you need to find an angle that is coterminal so you can graph it. I found 300 degrees, so I'm going to graph that angle, 90, 180, 270. So I'm down here in the 4th quadrant. Go ahead and drop your perpendicular and draw out your angle. So this time we rotated a total of 300 degrees. We need to figure out what's left. So I'm going to take the 360 and subtract the 300, which is what we rotated, and that gives you a reference angle of 60 degrees. So go ahead and pause and see if you can set up the sides. Remember, the smallest side will be opposite the 30-degree angle. See if you can set up the sides. This side will be positive as it moves to the right. This side is negative since we're moving in the negative direction here. Hypotenuse is always positive. Label your sides if you haven't already. This is x, the hypotenuse is r, and the other side then will be y. Okay, go ahead and set up your 6 trig ratios, and again, your angle is 1020. Use page 22 if needed and set up your trig functions. Okay. Okay, check your first three and then go ahead and do your reciprocals of those three. Check your answer, and you're going to need the calculator for the last set of problems. So it says to find the sine of 42 degrees 18 minutes. Before you do this, you've got to make sure your calculator is in the right mode. So go to the mode key, which is right next to the second button, and you want to make sure you are in degree mode, not radian. If your calculator looks like this, see how radian is highlighted? You need to arrow over to degree and hit enter in that mode menu. Okay, so you just go to mode and you go to degree and then just hit clear to get out of here. Okay, I want to type in the sine of 42 degrees and I don't know how to put in 18 minutes. So what I have to do first is divide this by 60. So I need to clear this out, and I'm going to divide 18 divided by 60. And that means I'm going to put in the sine of 42.3 degrees into the calculator. So type in sine 42.3, and we're rounding it to 6 decimal places. So I went 673,013. That 5 makes that round up. Okay, now this is a secant, and I don't have a secant key in my calculator. So you'll have to refer to page 29 to see the reciprocals. And if you look at page 29, secant goes with cosine. So we do have a cosine button. In order to put that in, we're going to do 1 divided by the secant. Before we do that, though, we've got to figure out what decimal this would be. So I'm going to take the 12, and I'm going to divide by 60 to figure out what decimal I'm going to put in. So it's going to be secant of negative 212.2 degrees. Okay, now don't confuse this with finding the angle. This is just simply a complete flip of this. This is the reciprocal identity. So instead of the secant, I'm going to type in 1 divided by cosine theta. So actually, this may look a little confusing. Let's write it this way. So instead of secant of theta, we're going to put in 1 divided by the cosine of theta. So we're going to put that in its place. And I know what theta is, so I'm going to go ahead and put it in the parentheses. You do not have to worry about coterminal angles here because we're using the calculator. So go ahead and type it in just like you see it. Please notice that I used the negative key at the bottom, not the subtract key, and I'm going to round this answer to 6 decimal places. So it's just 181,763. In this example, we're finding theta, so we're not going to be doing the regular tangent. Instead, we're going to be working with the inverse. So theta equals, we use tangent, but we're going to use the inverse of the tangent. Anytime you are missing the angle, you're going to use the inverse. Okay, I'm going to copy that number into the parentheses. To get the inverse tangent, I'm going to type second tangent, and then I'm going to type in this number. And just like the others, I'm going to round it to 6 decimal places. So again, I'm looking for the angle on this one. But the problem is I cannot use the cosecant key. So I'm going to need again to refer to page 29. Instead of the cosecant, I'm going to be using the sine button. And sine is the same as 1 divided by cosecant. But this is different than the ones we did in the last 2 examples. We have to put the sine next. We're still doing the inverse. You're still going to bring this number down. The difference is when you're putting the 1 divided by for this one, the 1 divided by is going to have to go inside the parenthesis, not in front of the question. So this time the 1 divided by goes in the parenthesis. So go ahead and type that into your calculator and round your answer to 6 decimal places. These last 2 questions, you can just try them by typing them into the calculator. If you take the sine of 90, you want to see if that's equal to the sine of 60 plus the sine of 30. So I'm going to try that out on my calculator. So I just typed it in. The sine of 90 was 1, and I'm going to put in the sine of 60 plus sine of 30. Notice how I closed the parenthesis this time? And this equals 1.36. So the question is, are these 2 equal? And you would say, no, this is false. And again, I just compared them in my calculator. Okay, so same thing. I just took 90 minus 35. I got 55. I took the tangent of 55 there. I got that number. Cotangent is the same as 1 divided by tangent of 35. If I type it in, you can see that I get the same answer. So these are equal. So this last one is true. That wraps up this problem set. Have a great day.